Okay, we're going to have a little, I consider these kind of diversions. They are helpful about how we use good reasoning strategies to solve problems. So non-routine problems. Yeah, that's what a lot of life is all about, right? The non-routine. We can, in those cases, make a table, look for a pattern, see if a pattern emerges as we put together some of our numbers. What three whole numbers have a sum of 15 and a product of 105? Wow, how to approach this? You have any ideas? Prime numbers, right? We should be using prime numbers. Let's see what our hint is here. Try factoring. Oh, yeah, we'll factor it into prime numbers and make an organized list. Okay. So obviously 5 will go into that evenly, so I'd have 5. And 5 would go in how many times? 21 times. And 21, what will that factor into? We're lucky, it only has 2 factors. So there are our 3 whole numbers that sum 5 plus 3 plus 7 equals 15 and have a product of 105. How about this one? A sealed, so we don't know what's inside, right? A sealed box contains hardbound and softbound books. The hardbound books weigh 3 pounds each. The softbound books weigh 2 pounds each. The box itself weighs 15 pounds. What are the possible quantities of each kind of book? Well, let's do some sort of a list here. If they were all hardbound books, it would be, let's see, 3 plus 3 plus 3 plus 3 to equal 15. So in that case, we would have 5 of the hardbound. Well, could we have all of them softbound? No, we couldn't, because it's 15 pounds and 2 pounds just won't go in evenly. What are the most softbound books we could have? 2, 4, I'm talking pounds now, 6, 8, 10, 12, and I'm going to have to stop there, aren't I? If I'm going to get to exactly 15 pounds, I now have to add 1 hardbound. So I could have 1, 2, 3, 4, 5, 6, 6 softbound and 1 hardbound. Now let's think what else we could do. I could, up here, convert 2 of my hardbounds into 3 of the softbounds, right? And I'd have that would be 9 pounds, and then add 2 to 11, another 2 to give me 13, and another 2 to give me that would all add up to 15, wouldn't it? So I could have 3 hardbounds plus 3 softbounds. And I could, what else could I do? If I think about this possibility of converting those into 3, I've got this one here. If I think from down here about converting these into 2 hardbounds, I've got this model right here. So I think I found them all. Maybe not. I've looked at it before, so let's see. In my earlier consideration, oh, isn't that strange? In my earlier consideration, I didn't even consider. Oh, I know why I didn't consider this one. Let's read this carefully. You probably did, and I didn't. It says the sealed box contains hardbound and softbound books. So this one was never a possibility, was it? I had to have some softbound books, so I only had 2 possibilities. Reading the problem, so important to read it carefully. The figure here has 3 triangles in its base. Well, let me just highlight those for us. So 3 triangles in its base. There they are. And it contains 9 small triangles. So we have these 3, then we have 1, 2, 3, 4, 5, 6, altogether 9 small triangles. How many small triangles would it contain if it had 15 triangles in its base? Now, this is a case where we might want to not only use the one we've got here, 3 triangles, oops, I'm putting it in the wrong place. I want to say 3 triangles in the base gives us 9 triangles. If I had only 1 triangle in the base, how many triangles would I... Oh, I'm still putting it in the wrong place. I would have... If I had 1 triangle in the base, that would only be this 1 triangle. If I had 2 triangles in the base, we'd be talking about this selection here. 2 in the base, 2 additional ones would be two in the base, 2 additional ones would be 4. Now if I put a 4th one in here, imagine that one there. So if I added one more here, how many additional triangles am I adding? So now I've got 4 in the base, and instead of having 9 total, I've got 1, 2, 3, 4, 5, 6, 7, plus 9, 16. Suppose I put 5 into the base. It's getting a little tricky for me to draw this, but we can imagine, can't we? We'll just have to make them a little bit misshapen. I just probably didn't organize this properly for us. So if I added still another one, so I had 5 in the base, 1, 2, 3, 4, 5. How many additional triangles did I just add? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 on to 16, 25. I'm going to clean this up a little bit. All right. Now, as you're looking at this, what do you think? Do we see a pattern? is there a relationship becoming obvious to us between the base and the total? If we square 1, we get 1. If we square 2, we get 4. If we square 3, we get 9. If we square 4, we get 16. If we square 5, we get 25. I think we have a relationship of base squared equals the total, which we would never have seen without taking a little time to make this table and to look for the pattern. So if that's true, how many small triangles would be contained in this figure if it had 15 triangles in the base? We're going to square that. If we square 15, what do we get? I think that's what we get. Because I didn't need that. So we would have 225. We're about to end, as you just saw. I just wanted to show you what we've done so far for reasoning strategies in this course. We're almost always writing an equation. And in fact, we weren't really writing an equation for either one of these. But for this one, we did write an equation. So you don't always do it, but sometimes it turns out that way. The ones that we have covered so far, we've done the organized list thing. In today's lesson, we were making a table. We've certainly, and we've known this one forever, this is the guess and check method, looking for a pattern. We did that today as well. Drawing a diagram, that I think is very often extremely useful. It certainly was useful for us solving this problem. It would have been hard to do without that figure. And then combining strategies, although I'm suggesting here we don't see it until we get to chapter 14, we actually combined strategies today. We made a table and we looked for a pattern. Done.